Hi everyone, welcome back to Talking Shop at 3DXTECH. As you remember, I'm Rachel Rogers, Product Manager here at 3DXTECH, and today we're joined by Bobby Clays.
Hi, I'm the Director of Marketing at 3DXTECH, and happy to be here for this episode and looking forward to diving into all this fun stuff with you.
Perfect, yeah. So from a marketing perspective, we're excited to talk about polypropylene carbon fiber. That has been one on the docket for a long time. I know we've had a lot of requests to bring it back, and we're excited to say it is back. It's back in stock right now on the website. Mm-hmm. Bobby has confirmed for me.
Yes, it have, and seems like everyone else is catching wind of it too, which is great.
Yeah, so, getting some orders same day.
Yes.
I don't know if you guys signed up for mailing lists or what, but that's very impressive. So this one is, we worked to do a balance of making it the same polypropylene carbon fiber you guys have known and enjoyed and relied on, while just optimizing it a little bit. So one of the big things here, we never want to get content with a product. We never want to just have it sit for years in the same formulation, because technology, especially in the additive space, is always improving, always growing. There's new types of polymers always being developed, new iterations of current polymers that have better layer adhesion, better melt speeds for shorter hot ends, higher temperatures, things like that. So this is a moment we took to iterate on that material, make it a little bit better, and just bring you something that is familiar enough. You can print with the same profiles that you were using before in a majority of cases, but you'll actually see a little bit of better mechanical performance, and in my opinion, and the opinion of our print techs, a little bit better layer adhesion and some interesting ESD properties. So that information will be on the technical data sheet. You can find that now, but it's a very interesting material, very low density, has a lot of good rigidity without sacrificing impact resistance, which is great. One of the big things of that too is polypropylene works very well at a very wide range of temperatures for applications, making it good for things like sporting equipment or any applications that might be, in the atmosphere, such as drones, anything like that, because low density is very important for situations like that.
Yeah, great. No, I guess kind of going off of that, I know a lot of customers have been asking for this to come back, so just highlighting, I guess, what do you think is the appeal for this particular material that people really wanted it to come back so bad?
Yeah, definitely. So I think the biggest draw for this material is how inert it is, as well as how low density it is. So a vast majority of the people that we have spoken to on this have used it for things like sporting equipment, any more like electronics that are going to see decent impact but also need to be lightweight. So like I mentioned, drones, we have a lot of people who have printed frame bodies or accessory equipment for their drones, because obviously that takes a lot of energy to get that heavier material up in the air. And then the stiffness aspect of the carbon fibers as well is a big draw for a lot of people. So this material uses some of our more engineering grade carbon fibers, so they're the slightly more long chain carbon fibers. They're not carbon black or any spheroidal carbon additives like some other materials are. This is one that is actually a carbon fiber that adds rigidity and stiffness to the finished part, which I think is great.
Nice.
Yeah.
Great.
And in that it does add some conductivity too, like I mentioned. This is a very interesting one. So far our prints have been very layer line and directional dependent for that conductivity. We've seen results anywhere from 10 to the third ohms in the actual direction of the print, and then 10 to the 12 in direction of the layers. So it seems like it's a material that does not really want to jump layer lines much in terms of conductivity, but when you actually follow the channel of the print itself, it is relatively conductive with electricity, which I think is a very interesting application. It's something that I think will be relatively technical to grapple with and master, but in my opinion, those possibilities are pretty endless, because you can actually choose what directions on a final print you want to be conductive and what ones you want to be inflative.
That's cool.
Yeah.
Very cool.
Isn't that
nice.
super cool? We're still trying to figure out some of the very ins and outs of that, just to get you guys as much information as possible so you can be successful with that material if that conductivity is of interest to you. But we're hoping to have that finalized in the next couple days, so possibly even before this video goes up. But we'll see.
Nice.
Yeah.
Very cool. No, I'm very excited to see this come back, and I know a lot of our customers are too, so
Yeah,
Very
there's
cool.
nothing really like it. There's a lot of alternate materials you could use in a pinch, but I think this one is very particular, very unique, very niche, and a lot of people have been wanting it for a long time. I think you used to get almost weekly emails.
Yes. No, I it's nice to be able to have a good answer now that this is back, and I know a lot of people are very excited for it. So.
And I'm no longer giving you Q2, Q3,
Yes.
Q4 timelines.
But I don't need to go into that.
Nope, we don't talk about that. So I think that's the thing that I'm most excited about. We've been enjoying the 3DX Labs materials that have come out in the last few weeks that we talked about in the last episode. So the PIBA, PVDF, GF, high temp PET G, similar. We've been really enjoying how those have been received so far.
Mm-hmm.
We've had a lot of technical questions. You've sent me quite a few, which is awesome.
There have been a lot, which, I mean, understandably, these are very, very new ones. So a lot of technical questions definitely over my head. So sorry for bombarding you with all of them. But
I think it's great. Well, the fact that you guys have applications that are so technical as to need some nitty-gritty data that we didn't have offhand. We actually did some supplemental testing per request, which was really fun. We love that we can respond to customers that quickly and with that level of detail. We try to be as accessible as possible. Now, in that bombardment he mentioned, it might take me a couple days to get back to you on the more detailed questions, but we love that we have customers that have applications specific enough and particular enough to need that level of detail. The fact that you guys have trust in our materials to try them out and truly put them through our paces is fantastic. I think, man, other than polypropylene CF, I don't have anything I can talk about right now for R&D stuff, but honestly, I think something important and a draw of the polypropylene CF too is it is not hygroscopic, so it does not want to absorb moisture. Obviously, recommend, as with pretty much any material, you do dry it a little bit just to get any surface level moisture off of the polymer, but this one's really nice. It does not want to absorb a lot of moisture, which is a very good draw. You can just kind of plug and play very quickly.
Oh, nice.
Not always the case with some materials. So like our PIBA and our high temp PET G are more hygroscopic, as well as a lot of our engineering materials. So I kind of wanted to talk about that today.
Yeah.
You get a lot of questions.
I do, yeah. And I mean, I have the same question too, is I guess how would someone know if a material does need to be dried and if they don't need to be? Like, is there a quick, like, just properties that you can look at, just a naming convention? Like, what's a good takeaway to know, like, this filament would need to be dried and this one can just be like plugged in and ready to go?
Yeah, so a lot of that does come down to a general knowledge of polymer chemistry, although on our website we do reference drying temperatures if it requires drying. If it doesn't, a majority of polymers, if you want to be really safe, a majority of polymers do require drying, whether that's just for 2 hours at 60 C or 8+ hours at 120 C, even 150 C, totally dependent on the material. Generally, I say the more engineering you get with materials, the more likely they are to need to be dried. So PLA you can generally get away with, although as some people know, it's very grade dependent, and any additives you put in it can impact the level of moisture that it absorbs. Even things like colorant can impact that. So that's a discussion I've really enjoyed having with some of our customers, and then also seeing on like forums, YouTube comments, YouTube channels has been really great. I think that's a really important discourse, is you cannot just paint everything with the same brush. It's very specific to the polymer.
Yeah, okay.
Which is part of the fun.
Yeah,
but
makes sense.
Materials like ABS, ASA, nylons, and then obviously going into the higher temp materials, I jump immediately to PEEK, PEC, PEI. Those are incredibly hygroscopic and need a lot of drying, and they need to be maintained very significantly to operate properly. You will see changes in the print properties and the print behaviors and that surface finish like that. So
good to know.
Yeah. Nice.
I know that's a common question, and I know when we hear sometimes customers having issues with prints with certain filaments, that could be a common culprit of print failures on it too. So that's good to know to definitely check it out before actually starting to print. Save yourself some time and money with it. So
definitely. Yeah, it's it can be very tricky, and if you don't know what you're looking for, if you're new to 3D printing, which you only know what you know. That's not an inherent piece of knowledge for a lot of people, which is absolutely fine. That's why we love the education aspect. But if you don't really know what you're looking for, suddenly seeing a print that was beautiful yesterday you reprint it and suddenly it looks horrible. That can be really confusing for people, and understanding the why and not immediately jumping into either thinking the material is faulty or that the machine is faulty and immediately jumping into replacing hardware is very important. We would hate for you guys to have to do that. So we try to give as much information as we can about moisture content, but generally we say lean on the safe side. So we do try to give you guys as much information and also equipment as possible to help mitigate that, especially for your higher temperature materials like our FM1 and our FD1.
So my next question is, what would you recommend people to use to dry filament?
It's really budget dependent. We try to keep everything as manageable and approachable for people as possible. If you're just printing for hobby, or you have the start up of a shop and you don't have a lot to work with, a lot of times we say you can technically dry it in your oven, although, check with the people who generally use your oven, because it can, once in a while, like ABS can leave a little bit of a smell, things like that. But they do sell, there's desiccant dryers, heated dryers, and then also like desiccant maintainers that you can purchase on the market, anywhere from, I think I've seen ones for like $50 for a single reel dryer, all the way up to a couple $1,000s for the more industrial grade ones. We love trying to capture as many people in the market as possible, anywhere from hobbyists all the way up to industrial companies that are printing en masse. We generally, for our equipment that we use for moisture control, we do lean a little bit more into the industrial side, but I think it is worth it, especially if you're purchasing some higher grade materials. So that's where our FD1 and our FM1 come in. Those are our filament dryer 1 and our filament maintainer 1. We actually designed the FM1 in-house. That was a labor of love for me for a while.
I know someone that had their hands on it.
I love it so much. But it's something that we made to kind of mitigate our own frustrations with our filament absorbing moisture over time for our print shop. But we're trying to print test bars. Got really obnoxious, so we decided, hey, there seems to be a gap in this market. We want to have something that's a little bit smaller, a little bit more down to earth than a lot of the truly industrial company-sized dryers and maintainers that exist in the market, but also not have it just be, a single reel at a time, because a lot of times if you have a bigger shop or you're running a little bit more detailed equipment, you have more than one reel that you need to dry. So. I don't know, what are the features that you've seen on it? You're the one who builds our website and everything, so you're putting all the blurbs in. Is there anything that stands out to you?
I know the one that really is a big feature, especially when we go to like expos and events to showcase this, is the feeding ports from, especially the FM1, if you're going straight to the printer, how you can just leave the reel right in there once it's dried. And people can know, like, my filament's not going to get wet, and just feed it directly from the feeder right into the printer. They can that way pick up some of our bigger reels for the longer prints and not have to worry about like lag time of switching reels out, and everything just stays maintained. So I know that's a huge feature for a lot of our customers with that, and the fact that if you get the FM1, FD1, they stack on top of each other nicely, so space really doesn't take up too much of that. Another big feature is our bundle deal for it. I think if you buy them both, it's like $1,500 off, I believe.
I think so.
Yeah.
You dictate that. I don't dictate that.
I believe it's $1,500 savings if you get them both. Which, I mean, most people, usually if they get one, they get the other. So it's a great savings to really get that in their shop.
Yeah, that's awesome.
Yeah,
biggest thing with that, the reason we recommend it being purchased as a bundle, if you maintain wet material, emphasis on the word maintain, if it's wet, it'll stay wet. If it's dry, it'll stay dry. So generally we say the FD1 you use to dry the material first off. So you're making sure that it's at that lower moisture content that you need, and that's per our website recommendations for drying. You can look at any of the product pages to get the specific times and temperatures we recommend drying at. Our FD1 goes up to, I believe it's 120 C. I don't think we put it up to 150. Maybe we did.
Maybe.
I limited it in the software.
That's all I
remember.
I'm trying to
remember. I'm trying to remember. I don't think we put it at 150 because the majority of the materials that dry at 150, like peaks, PEIs, and PECs, can dry at 120. Just need more time. I'm not going to go into that whole thing of time versus temperature dependency.
That's episode 3.
That is probably an hour plus of discussion on its own of just the chemistry of that. But So our FD1 can dry, and the cool thing too is you can program it to ramp up temperatures and then go back down in temperature. You can use that for annealing actually too, which is a huge benefit. It's a pretty big oven as well. It's the chamber itself is, we fit 3 2Ks in there, I believe. And then if you want, you can put one askance at the top too, if you really want to Tetris it up. But so it's a relatively big chamber. It's not a single real unit. So it's truly an industrial piece of equipment, and you can program it so you can have it auto turn off. So you don't have to worry about over drying your material, particularly for nylons. You can over dry it. So we recommend setting programs so it does turn off once that cycle is done. It stays relatively moisture controlled on that in that chamber, even when the heat is off. But
very nice.
Obviously recommend drying and then moving over to that FM1 to maintain it. So our FM1 has 2 desiccant dryers that parallel with each other. So they are constantly regenerating as well. You don't have to dry the desiccant, which is a huge benefit. This is not like an AMS where you have to take the desiccant out, dry it, put it back in manually, because it's useful for the AMS when you have an industrial piece of equipment. You do not want to waste your time drying desiccant. Nope. So one unit is always drying while the other one is regenerating. So the chamber, the actual chamber, is always having dry air pumped into it at all times. So there's never dead air that's sitting and collecting moisture. Obviously, it's also very airtight. We have a lot of really good sealing on it. But we just like to try and make sure that it is remaining in that, because we have the assumption that you guys are going to be filling it with PEEK. And that's a lot of money to have suddenly wet material.
Yep.
We don't want that.
We don't want that at all.
No downtime, please.
Yes. Yeah.
So I think that's, I get very passionate about that because moisture, like I mentioned earlier, is a topic that a lot of people either don't understand or they don't understand the full impact that can have. Not only does the surface finish suffer from moisture content, but you don't get the layer adhesion that you should. And when I don't know if anyone here is printed with material that is very, very wet and prints very, very hot. It's a little scary. It evaporates out of the material as it's going through the hot end, and that snap, crackle, pop of $1,000 filament is not a good sound. So we really try to minimize that so you can maximize your mechanical performance of your finished parts.
Nice. Well, very nice.
Yeah. Man, I think that's probably, without going too much on my soapbox about moisture content, because you can get really into the nitty gritty. There are a lot of good resources online that you can look up about moisture content, what materials are more hygroscopic, what ones are less so, why that matters, the fact that nylons can get too dry versus too wet, like PLAs, PETGs. Generally, you can dry those forever, but nylons you can't. And if you guys want to know a little bit more of why, you can either just look it up and read some white papers, or you can let us know and we can talk about it more in a different video.
Nice.
Yeah.
So essentially, FM1, FD1, great solution for this. And then if they need to figure out what filament needs what drying resource, our website usually has those settings on it.
Oh yeah, I think it's a very good resource, and it's very material dependent too. It doesn't just have a general statement about it, but to be very safe, we do recommend you dry everything. Our packaging, we work very hard on our packaging when we send you guys finished goods. We dry all of our material prior to shipping it out. We put a bunch of desiccants in the reels, probably more than needed. We like to err on the side of caution with that because we understand this might be going across the world to someone, who has to wait 6 days goes across the ocean. Yep. We want to try and mitigate any sort of risks with that. But also, we have very heavy duty bags that are, vacuum sealed, everything. But we do recommend, just to be safe, if you really want to make sure that your first print with that material is successful, especially the more expensive stuff, dry it a little bit per our recommendations on the website. Just going back to the FM1.
Oh, okay.
So as you mentioned, we have larger reels that a lot of our customers print with. We do actually have some customers who have been able to print week plus prints without stopping.
Oh, wow.
Which is, it's awesome, especially for like aerospace like applications. There's some very large prints that are done with our equipment, and the fact that they can print out of the FM1 without stopping is huge, because you do lose time just doing changeovers, because they have to purge purge the material out of the nozzle, put it back in. Obviously, there's the potential for any sort of equipment failures, which is so unfortunate when you're 36 hours into a 64-hour print. I have experienced that, and
a lot of people have here, and usually you hear about it throughout the shop.
Pretty sure I've cried. Yeah, it's great. So with that, our FM1 has modular system, so it has a rack that you can store a bunch of filament on without moving it. But if you want to access those ports, that rack is stainless steel, so generally those reels can run on it. We have a whole manual. It's great. But then we also have a secondary piece. It's shaped in a triangle because we're all about triangles and hexagons here. Branding's so important. But you can actually go on the center spool hub and feed out of it, and it's very low friction. So I don't know if I've ever heard of a failure being experienced by it catching, unless it like jumps off, which I think I heard of one instance of that, and they were going. Yeah. I think it was during a purge, actually. So I wouldn't even count that as a print failure necessarily, but so it has a center spool hub that you can print off of. And with that, we have found a lot of success in putting it into a bunch of different printers, like the 22 IDEX, but also the Stratasys equipment, specifically the Fortis machines. We've had customers who print, like I said, week plus prints with into the Stratasys directly. And with that, we actually do sell a chip cradle. And with that, it is an adapter where you can put the tubing that goes directly from the FM1 into the Fortis.
Oh, nice.
So there is no air gap of that material. It's all tubing. Obviously, that's not vacuum sealed like the rest of it is, but it really minimizes any moisture exposure that material is going to have, and it makes sure that it's compatible with the chips. You're not going to have any read failures with the Fortis.
Oh, nice.
And it basically tricks the equipment into thinking there's a canister in there, and then you can just print endlessly. So we write chips specifically for the size. So if you buy one of our huge reels, we will write the chip to accommodate that, so there's no run out condition. You're not going to have it prematurely end before that material is actually gone.
Nice.
I think it's a pretty great system.
And that's what I was going to ask. If they're doing a week-long print, how big of a reel would they need for that?
So we sell 750 cubic inch reels of ABS and ASA specifically.
Yeah, that should do it.
It's big. Yeah, it's very big. And we actually have a lot of customers that have wanted that and have needed that and reorder, which is fantastic. I don't know how you go through that much plastic that quickly, but it'll be like monthly reorders. Carbon fiber versus glass fiber. Draws of carbon fiber. Lower density, lighter weight. Generally has some conductivity to it depending on the specific polymer matrix and the orientation of your print, which can be a benefit. Sometimes can also be a negative if you're trying to protect delicate electronics and you're concerned about that aspect. I would say also I think the lightweight perspective is really big. And then glass fiber, lower cost generally, a little bit more stiffness to it, a little bit more impact resistance. Negatives, a lot heavier. And then also sometimes doesn't have as nice of a surface finish, I've never experienced feeling glass fibers in my skin. Some people swear that they do. So if that is a concern that you have, generally would recommend carbon fiber over glass fiber. But a lot of the glass fiber is really good for just the robust, you're going to be kicking this thing down a football field or like down a mountain. We have a lot of people who do GF materials for like mountain biking or hiking equipment, which is very, very cool. So I think that's a big draw, and it's more colorable. It's really nice too.
So if you had to give like a quick synopsis of like what 3 projects for carbon fiber and like 3 projects for glass fiber, just to get like a general
that's a good one.
Quick
like some applications
which one,
aspect.
To kind of draw them, give them a quick head start of which one to pick.
Carbon fiber, drones, anything that needs a little bit of ESD aspect to it. So like cases for microchips or something similar. Although if you really need to be careful with that, ESD line, I would prefer that just because it's a little bit more specified toward that
Especially if that's your number one goal.
Exactly.
ESD,
yes. Yeah. But I think it's a good application if that's kind of a secondary for you.
Oh, good.
And then inertness, I think, is a big thing too, although the glass fibers are also inert. So I'd say probably just nice surface finish, especially if you're looking for like a black matte part. So things that need stiffness, like the assembly equipment on a chair or biking or something similar. I think carbon fiber is a big go-to. Glass fiber, stuff that needs to be stiff but fun colors. So like we've had people print cases for their computers, like hard shell cases or even suitcases.
Oh, wow.
That's a big one. And then I would say probably, yeah, I just want to say like sporting equipment. And then, man, that third one's tough. It has so many uses. That's the problem. We have so many people.
I know, and that's, I think, especially the glass fiber is the one that I keep seeing like an abundant like amount of different applications.
And that's so cool.
And I figured, why not put you on the spot to narrow it down to 3?
I was gonna say I have seen some people do like training assembly stuff. So like things for planes or whatever. If there's a piece that is used for like plane or boat storage that has to be removed for use. So the color has to be very indicative of like, hey, this cannot stay when the plane is in the air. That has been very useful for a lot of people to just say like, hey, here's this bright red piece that needs to be removed, but is robust enough to be taken off, put back on, and put in storage multiple times.
Oh.
I think that's a big one. Bam,
Nice.
got it.
Nice. Well done. That's 3.
And done. No, thank you guys so much for tuning in. Really love having these more detailed discussions. If you guys have anything else you want us to talk about, we would be happy to. Just put it in the comments. Ask me any questions that you're interested in. Have a great rest of your day. Bye.
Thanks, guys.